The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. I'm Kendall Trump with Grain Journal Magazine in Decatur, Illinois. Welcome to Utilizing Laser Scanning with Your Next Facility Project. This is the sixth in a series of webinars to be presented by GEAPS in Grain Journal Magazine in 2019. Today's webinar is sponsored by M&M Specialty Services. M&M specializes in protecting your people and your products with the best in quality and affordability in personal protection products, grain protectants, fumigants, and services. They are based in Leavenworth, Kansas. This webinar is also sponsored by VAA LLC, who has provided engineering and design services in the agribusiness industry since its founding in 1978. Working with owners, equipment vendors, and design-build contractors, the firm specializes in bulk commodity handling facilities, including slip-form design, material handling, transportation, and export. They are based in Minneapolis, Minnesota. Our presenter today is Ross McElhenney. Ross is an experienced project manager with a demonstrated history of work in the food production industry. He currently works at LDC as a products manager in engineering. You can participate in our Q&A session today by typing your questions into the questions box at the right-hand side of your screen at any time during our presentation. We will be addressing your questions during a Q&A session following the webinar. We do have one polling question for you today. How many people are viewing at your facility? Thank you all for your participation. As a note, today's webinar is being recorded and it will be posted to our website, grainnet.com, within 24 hours. All registrants will also receive an email containing a link to the recording of this presentation. Ross, at this time, can you please do a voice check?
Yep, I'm here.
Great, we can hear you. And
Perfect.
now can you please show us your screen? Ladies and gentlemen, here is Ross McElhenney.
Hello, everyone. I gave this presentation at Exchange this last year, so it's, if anybody was there, they may have already seen it. I'm going to take some of these things a little bit more local to my machine so that I can show you how some of the pieces actually work. But the presentation's on utilizing laser scanning. Our company, over the last 5 or 6 years, has completely changed our workflow. What we found is that we really no longer could use the existing as-built drawings, the existing plant layouts and stuff over time because most of our facilities are leased. Those pieces of information were no longer good, so we had to find a way to be able to quickly map a facility so we could install new equipment. So what we've done is we've completely moved to a workflow that requires us to LiDAR scan or laser scan our facilities. We've also moved to using a drone technology, which I'll show you. Basically, each one of our facilities, what we do is we start with a virtual environment, which is a 3D laser scan, which I'll show you some pictures of in a minute. From that point, we move and do a demo, which again, I'll show you that. We basically do a virtual demo of the thing, and then we do a virtual build. How does laser scanning help us? Again, our existing drawings are out of date. They're really no good. We've not done a good job over the years of having as-built. Our installers have installed equipment that doesn't exactly match the drawings. So as we try to put equipment into these brownfield facilities, those pieces of equipment are just simply don't fit. We had a lot of collisions and quite honestly a lot of cost on these projects that were because the existing knowledge of these facilities was so poor. And typically our prints do not show things like electrical boxes, conduit locations, compressed air lines, everything that we expect in these facilities simply doesn't show up in the drawings, but does show up on our laser scans. And basically the real world is crooked and crazy. There's really no straight lines, round circles. So we needed something to pick that up. We wanted a way to design equipment so we could slide it in within a half an inch of the existing equipment. That can't be done with old school technologies. The advantages of the scanning, we don't need existing drawings, and I've said that a couple times. We simply scan the area, create a cloud point, and then during the construction process, we can actually measure against the models and the cloud points to see if the equipment's going in exactly as planned. We also use the drone technology and the scanners to scan for things that we wouldn't have looked for before. We scan all of our rebar in the concrete before we pour the concrete as a proof of placement. We scan electrical down in the trenches if we have to bury electrical, so we know where all the conduit boxes are. And then the designing in the cloud point environment basically lets us avoid those interferences that we already had in the facility that just simply weren't on the drawings. I don't know about you guys, but my drawing sets in these old facilities, some of these things are 50, 60 years old, and they've been water damaged, and they're simply abused. The other thing that the scans will bring up is it'll show us the bent and damaged parts. So a lot of times these facilities have been beat on in various ways, and the equipment has been moved around. This will actually allow us to avoid interferences for the existing facility. Again, electrical parts aren't detailed in any of our prints. Typically, they'll be one-liners, show electrical goes from here to there, but it doesn't exactly show where each conduit is. The picture that I show here is actually a place where we had to replace the conveyors underneath this electrical, and we had to come within a half an inch of this electrical, and there was no other way other than to scan it. What technologies are available and what do we use? Our main technology is to use a LiDAR scanner. It stands for light detection and ranging. They're extremely accurate devices. We have a FARO 330 that we use constantly. It's in the field pretty much all the time. The advantages, they're fast. You set up a single point scan and it will pick up around 2 million points per second of accuracy. And I'll show some pictures of what these points look like, but basically they're a free point in space that has an XYZ coordinate to them. They're measurable, they're actually colored, so they look like photographs, and they're extremely accurate. Again, over 1,000 feet we range plus or minus 2 millimeters. That's way better than any other drawing that I have. Angular accuracy, I show it on the presentation. It won't mean anything but 19 arc seconds for vertical and horizontal, which is quite accurate. Captures a really rich point cloud, which I'll show some presentations of here in a minute. There's some disadvantages. Line of sight. Basically, a laser is a beam. It goes absolutely straight. So you have to set these up in multiple locations to get presentations from all sides of the thing. And again, I'll show some of these in a minute here. They are expensive. You can buy a used LiDAR scanner in the $25,000 range. A brand new setup, latest technology, all that nice stuff is in the $90,000 range. So they're expensive, but I've paid for my LiDAR scanner at least 10 times. Suppliers that we use and recommend, again, I have a FARO 330. It's the one shown in the upper picture. They have a newer scanner which is twice as accurate. Obviously at $90,000, we're not really going to go out and buy another one since ours works perfectly well. And then Leica is the other manufacturer. If I was to go buy a scanner today, I would buy a Leica. They're much faster. they have the advantage of being able to do registrations, which again, I'll show you some of these things in a second, but they let you do registrations on site, on the fly, and they know when you move them, how far you've moved them. So the whole process with the Leica scanner is faster. It's really no better than the Faros, except for the fact that a Faro scan for me takes about 11 minutes a scan, and a Leica scan takes somewhere in the 2.5 to 3 minutes a scan kind of thing. That adds up as you do these in the facilities. We again scan each one of our facilities. This is a facility we have in Seattle. It's a grain elevator and a ship loading facility. That what you end up with these 3D scans is very highly accurate positioning of all the equipment. They do tend to be a little bit pixelated, but again, that's a very high density for measurements. We do use drones and use photogrammetry and orthomosaics. Those basically give us similar cloud point scans. They're not quite as accurate, but for getting to places, tops of buildings, tops of conveyors, all those things, we can merge the information from the drone photogrammetry in with our LiDAR scans, and so we'll get a complete 360-degree view of all of our equipment. What do we see, and what do we do with the drones and why? The drones imagery is automatically uploaded to the cloud. I'll show you the website and how we go about doing that. Its accuracy is about, that's 2 to 4 pixels, which is about 1 centimeter. It captures a really nice point cloud. Disadvantages, it only works where you can fly, and you do need a commercial drone license. They're not particularly hard to get, but you need to do that before you can fly. Once in a while, you get yourself caught in a place where you can't fly legally because of flight restrictions. They're not quite as accurate, as I said, as LiDAR. This is a picture of a drone scan of the same facility. You can see that it's a little bit more pixelated, but again, highly accurate and quite capable. I'm gonna switch over to the drone software here real quick to give you an idea. This is that same facility in Seattle. This is a series of flights, about 300 photographs of the facility that we've turned into an orthomosaic. This took about an hour to fly and process. So you get very good accuracy in a very short amount of time. Again, very rich information for something you do quickly. We merge these along with our LiDAR scans, so it gives us the ability to build 3D representations of these facilities very rapidly. The other technology, and quite honestly, we don't use this one, are handheld scanners. You'll see a lot of them out there. They're good if you're going to scan the inside of your car or something like that. They really don't work well. They're slow. They're very sensitive to exterior light sources. They're expensive and complicated, and we just haven't found a home for them. The other useful device that we do use we use VR viewers, virtual reality viewers. I have an HTC Vive, which is a headset and a ranging thing that you set up in your office. We do virtual reality walkthroughs for our facility. We do them from a safety standpoint. We'll put the safety managers and stuff under the headsets, and we do it from an interference standpoint. That we literally put our operators and people in virtual reality headsets and let them walk through these facilities as they are constructed. Again, software, AutoCAD is at the lead of all this stuff right now. We do use SolidWorks, but AutoCAD Recap, AutoCAD Inventor, Revit, which is their building information modeling, and then as a free tool, we use Navisworks to pass these things around. They're really at the leading edge of this technology. Again, we use Faro for doing the virtual reality viewing and the CloudPoint registrations, which I'll show you in a minute here. We do use SolidWorks, but only for 3D modeling, and their CloudPoint capabilities is atrocious. They simply have stepped over that piece of the world and aren't interested in doing that, or at least don't show it in their software. So we tend to be tied to the Autodesk. The last piece that we use is we use 3D robotics for our drone point cloud registration. That software that I had up just a minute ago was there on their website for cloud points. Now I'll get to a little bit more detailed on how we go about it and what a cloud point is and how it fits. Our workflow basically, as I stated before, is we build a cloud point. And what is that? I'm going to open up the software for the cloud points. This is a software called Scene. What you're going to see is we will go out to this site, and on the left-hand side, you see I've shot 1, 2, 3, 4, 5, 6, 7, 8, 9 scans of the facility. What you end up with is a kind of a dot matrix configuration of the facility. I'll stop here in a second. And what we're working on is this stuff on the left-hand side, where I have an existing piece of equipment, in this case an aspirator, and what we want to do is basically replace it and put a new piece of equipment into it. So you shoot single scans. This is the output from one scan from the laser scanner. Again, very, very highly detailed, but it only shows one side of the equipment. And in this case, I'm sitting up on the deck waiting for the scanner to finish, because again, it takes about 11 minutes to produce this amount of information. Then what happens is you have to position the scanner in multiple locations, and you see pictures of the scanner on the screen. Those are the multiple locations that I set the scanner up. And then each one produces a portion of the cloud point. So basically each one of these scans, you can see on here where they were positioned, and each scan is its own thing. I'm going to move one out of the way so you can see it as what it picked up in that. And this software registers these pieces of equipment, or these scans, all together into a single basic mosaic of all of this information. From that, we can take and measure where each piece of equipment fits into, or we can measure the existing equipment that's there, and I can place 3D models into this facility. So I'm going to go back to my presentation. So basically what we do is we build and register CloudPoint. Oops, wrong one. That one. So we've built and registered this piece of this information. All it really is, if you zoom down to the bottom of this thing, let's do a better picture, okay, is a series of points, dots. Each one of these dots has a position in space, a 3D position in space. Each one of these dots has a color, and they actually are a plane, so they actually have a direction that the laser shot them at. So now you have a 3D representation, there it is, of the equipment that we currently have in place. Back to here. Then the next portion of this thing, after we've registered these all together into the one big picture, is you need to geoposition them. This is looks like a minor point, but you actually need to place these scans in relative position to the world around it. Basically, what we want to be able to do is pick on one of these points and be able to get a survey location from it. All of the software allows for tools to do geopositioning. Basically, you have to survey 3 points. You put those 3 points into your cloud, and then from that you can geo-position the entire cloud point so that it matches real world. And basically you can virtually survey points onto the thing. Then what we do is we create a demolition view. So basically what I've done, now let's go back the other way. And I set one up for demolition. So what we would do in this case is we would create a clipping box around the outside of this. And this portion is a whole lot like Photoshop. Basically, you're going to go in and erase the things that you don't want in the facility. And the easiest way to do that in these cases is I create a clipping box. So now this is the piece of equipment I'm not interested in anymore. We want to virtually remove it like we were doing a demolition in the facility. I would pick a piece of it and say, I'm not interested in this thing anymore. And delete those points. And you would very neatly go back and delete all the things that are no longer that are required out there, just like you were demolishing them mechanically. We remove all the unwanted equipment. Then we would come in and create 3D models. So here's the demoed view of that thing. I've taken all the equipment that we don't want in this thing anymore. We went into, in this case, SolidWorks, created a set of models. Views, visible. Okay, so now we've modeled up the new equipment, checked it for interference, done virtual reality walkthroughs with this thing. So now that new equipment is in place. And quite honestly, we can put this stuff in, and this equipment has been installed in this facility, and I missed that beam by about 1/4 of an inch, and that's the level of accuracy that we get. So now we've produced a cloud point and then installed new equipment into that system. From that, we now have a set of 3D models. I added those models to the cloud point. From that, we can do virtual reality walkthroughs. Let's go back up here. And we've gone through it. We talked about all these things, so I'm just going to skip through them. Registering, again, I did that on the fly for you. Geolocation, remove the unwanted parts, add 3D models. And then this is the output from a 3D virtual reality walkthrough. So you actually can physically get on the piece of equipment, look for gaps, look for places where your handrail doesn't meet OSHA, look for interferences underneath the thing. Basically, you can go through like you were installing this equipment. Our intent is to be able to do this in field and move to augmented reality. Those tools really don't, they exist, but they're really expensive and really hard to do. But basically, we get a virtual environment. The cloud point produces us a virtual environment. We build virtual equipment in the models, and then we virtually install it. So that when we install the real equipment, it's the second time we've installed it because it fits and matches exactly as expected it to. In this particular case, it's a facility in Claypool, Indiana. We put all the stuff in. Everything fit as planned, and it's now an operating facility. Oops. Okay, next slide. The next piece that we do use the scanners for, and we also use the drones for, is to track and manage. I'm sorry, I had just an interruption. We use it in our construction phase. We track and manage the progress of the project. We create detailed installation records. What's shown on this slide is basically the facility at 2 phases, one where we've done drawings and the second one where we're mapping the actual rebar that went into this facility. So you can see the before and after from the scans that were done before and then the scans that were done after the facility was installed. We use both our drones and our scanners for this, so we have intermediate progress scans of the facility. Allows you to see literally where the rebar is. If you want to go back and cut a hole in the concrete, you literally can go back and find the rebar and, you know, not cut a piece of rebar, drill in between them, that kind of stuff. It works lovely for electrical. We know where our conduit boxes are buried. You can literally dig a small hole, reach down and hit a conduit box. We manage and track our projects as we go, create detailed installation records, and then we actually compare the actual placement with the design. Again, this is one of the ones, basically, we have drawings of our rebar that we've overlaid onto the scans, and then we actually go back, place the rebar, and compare the rebar to the to where it was on the drawings. And we go bug the contractors about the fact that they missed a piece of rebar or it's not where it's supposed to be. So this is sort of the contractor's worst enemy in some cases. But you know, they've learned to live with it, and we've got built much more accurate, better facilities because of it. Some common misconceptions on this thing. We don't use our scanner to reverse engineer existing equipment. We're building a 3D working environment. That working environment is there, it exists. There's really no good reason to go back and 3D model the existing stuff. It's very expensive to go back and go from the 3D scans to an actual 3D model. We have seen effectively no value in that. We will go back and scan places and put some small pieces of equipment in so we have tie-in points, because the 3D scans really don't show well on drawings. They really work in the environment itself in the 3D. We only model existing structures where the equipment attaches. Oops. That's interesting. Sorry about that. We hold the amount of reverse engineering we do to an absolute bare minimum. It costs a lot of money, and we just haven't seen any value in that. And I'm gonna go back and, you know, I've kind of blasted through this presentation, so we've got some time to kill. I'll go back and show some of these things in the 3D environments that we can actually do that are interesting. Conclusion: using CloudPoint as a working environment can magically improves the construction accuracy and reduces installation errors while reducing engineering costs and not needing to reverse engineering the existing facility. We think we save something in the 8 to 10% range on these projects. That comes in 2 places. One is this reduces the amount of engineering that's required to figure out what you already have out there, and it dramatically reduces the amount of rework we're doing in these facilities. A lot of times we find in the CloudPoints pieces of equipment that didn't show up on drawings, or conduit boxes that are in the way, or lighting structures that are where we'd run into them. A lot of things like that we can pre-engineer and install them right the first time. It allows us to pre-engineer our structures. So I can bring a large structure into the facility and mount that structure directly to, say, a concrete silo without having to do a lot of field fitting. The difficulty that we do run into is when you start and you really do this, you start to believe in the model. That's generally a good thing, but these facilities breathe and move and do things like that. You still need to take into account some places to have some makeups. We have done these facilities flange to flange, bolt to bolt, and we can do that with enough accuracy that it fits. The difficulty is that you have to have caught 100%. So in the old school, you would have added pieces of spouting and stuff like that that they would field cut and do those kinds of things. Today, we don't have to do that, but you need to keep your wits about you from an engineering standpoint to make sure that you're allowing for those kinds of things. That's the end of the formal presentation, but I wanted to go through a couple other pieces of this thing that I can show you inside of the scan itself. Again, we use this on every project. We have effectively abandoned doing cloud point scans, or not doing cloud, or doing facilities without going back and cloud point scanning. We believe the cost of having the interferences and the delays, and the fact that we can pre-build a lot of this equipment. You know, in this case, we completely pre-built this structure that's sitting in here, brought it up in modular sections. It all bolted directly. The cleaner slipped in, the screw conveyor slipped in. You know, we get, again, I can't press upon you how much having this level of accuracy improves our ability to build things and put them in place. You can see in here, this cleaner literally just barely slips into this configuration. We built these spouts and spouting systems flange to flange. They basically welded one flange up here and dropped this thing in. So the installation of this took substantially less time. The accuracy was substantially better. We literally could tell them exactly which pieces of conduit to demo, which pieces of equipment to demo out of this thing. It dramatically improves the overall fit and finish of the facility. The other piece that we've moved to, I'm going to cheat over here to another facility. All projects. This is a facility we have in Indiana. We use the drone and our CloudPoint technologies to do our own surveying. Basically, what we'll do is we'll have somebody come in and place a certain number of control points, and then we can survey the rest of the facility within about a centimeter of accuracy, and we can do our cuts and fills from that. So our excavation cuts and fills are extremely accurate. So we basically have integrated this technology completely into the way we do business, to the point where we almost don't have a process to do things in the old school way. Go back. So I know this is a little shorter than I planned, but that's the conclusion to my my formal presentation. I'm opening up to questions and comments, and if somebody wants me to show them any of the other details, I'd be happy to do that.
Okay, thank you so much for a great presentation, Ross. This concludes the presentation portion of today's event. We will now begin our Q&A session. If you have not yet submitted your questions, please do so at this time. Okay, Ross, our first question, why do you use SolidWorks over Revit?
The answer to that simple. I started using SolidWorks with SolidWorks 1, and so I'm just a SolidWorks guy. I can't tell you how strongly I recommend that you don't do that. SolidWorks simply is not good for cloud point scans. I've done some of it in there. You lose a lot of texture, you lose a lot of accuracy. I'm just old school and have been running SolidWorks since '87, so I just don't know any better, I guess. I'm old enough that I struggle with learning all the details in Revit.
Sure. Okay. Our next question. Can laser scanning help improve the safety of my facility?
The biggest place we see improvements in safety is that we're doing virtual walkthroughs. So we can scan a facility, we can put people in a remote room. Maybe we have a safety meeting. We literally can bring those people into the facility and talk about those safety aspects. The other place that we're seeing safety improvements is walking our safety people through these as a 3D model and a scan. It's helped to get everybody on the same position, handrails, guardrails, slips and fall kinds of things. We've seen actually big safety improvements because of our our 3D modeling and our walkthrough capabilities. The other nice thing about it is I literally have all of these facilities on my desktop, and I can tell you from my desktop what direction each bolt is turned in those facilities. I have that level of details. We have a big facility in Port Allen, Louisiana, and I literally have about 400 scans of that facility, and I can walk through that facility just like I was there without ever leaving my desk. So that's a huge advantage when you're trying to operate multiple facilities from a central location.
Okay, our next question. Just for an example of time on site, how long were you on site for the example that you showed?
The example of Claypool, which is the one that the cleaner went in, I did all of those scans in about 2.5 hours. So I was on site a whole day because you obviously get there and go home and all that kind of stuff. But it took about 2.5 hours. And then at my desk in Kansas City, which is where I live, you would spend maybe another 2.5 to 3 hours registering those scans so that you have a cohesive model. The only caveat in that is I've done a lot of these, so I know where to place the scanner ahead of time, so I don't have to shoot near as many scans as somebody that went out the first time. The other a little difficulty is that the scanner is modestly heavy. It's 10, 12 pound kind of device, and you're crawling up and down ladders with that thing. That gets a little bit challenging to haul a $50,000 device the size of a football up and down ladders, hoping you don't drop the thing.
Okay, next. After you design the project, what does your scope of work look like that you would hand to contractors? Can you show an example of construction or demolition plans?
I don't have any prepared here, but I would say that our drawing sets look quite different than a standard 2D drawing set. We do supply full models to our vendors. Those aren't particularly useful because most of our vendors are not as advanced as maybe we are from a software hardware standpoint. But we do supply a thing that looks like a cartoon book. Basically, every piece of equipment, it's got a picture with it, it's got drawings with it, and the best example that I have is if you go to the store and buy a Legos box that has the Millennium Falcon in it, it's a series of find this thing, here's the picture of it, place it here, build from here to there kind of thing. And that's the way our drawing sets look like for one of these facilities. We are actually taking a big facility, a job for Port Allen, out to public bid, and those pieces of, that drawing set would be available for anybody that wanted to go and look at it. But I don't have one prepared to show anybody right now.
Okay, our next question. Can you spend a little time discussing the software that you use to store, index, and access your scans?
We literally are using standard Windows directories to put this stuff in. We do specifically have a pattern that we save them in. The difficulty is that these scans are very large. The computer that I run these things on has 15 terabytes of storage on it because these things get really big. So what happens is you end up compressing each facility into a single cloud point so that you can manage the data size. And then that is just stored. We just store them in standard directories for each one of the facilities. The actual drone stuff, we use the 3D robotics drone site, and we actually have those all in the cloud. So the cloud we can go to from any place and actually have a full detailed piece for the drones for each facility and each flight that was done for those.
Okay, our next question. Do you or can you program default standards into the new install so that computers can pick up on potential bottlenecks?
Don't know what that means.
Okay.
I don't understand the question.
Okay, we'll move on to the next one. What was the software that you used to virtually demo the aspirator?
That was there's two ways to do that. We use a thing called Scene, which is part of the Faro software. So I would have demoed it in Faro. It is equally as easy to do in Recap, which is an Autodesk product. You basically go through the exact same steps. It's just which of those two pieces of software you happen to use. The reason we use Scene is because their virtual reality walkthrough today is better than the one that's in AutoCAD. I think AutoCAD next generation, maybe this next release, will bring that up, and you'll be able to do better virtual reality walkthroughs in the AutoCAD piece. We've been talking with Autodesk about that. It's imminent. It's sitting out there. But right now, because we want to take things to the virtual reality step, we use Scene.
Okay, that is all that we have for questions today. Thank you all for your participation. If your question was not yet answered, it will be sent forward to our presenter and it will be answered. And that is all that we have for today. I want to go ahead and thank our sponsors, M&M Specialty Services and VAA LLC, for their support in bringing you today's webinar. And I also want to thank GEAPS and our presenter, Ross McElhenney, for joining us today. The GEAPS Leadership, Education, and Networking Workshop offers new grain industry professionals and experienced leadership alike an opportunity to sharpen leadership skills, gain practical insights, and expand their professional networks. All grain industry professionals, GEAP members, and non-members are invited to attend. The workshop will be held at the Intercontinental St. Paul Riverfront, July 16th and 17th. Please visit jeeps.com for registration information. As a reminder, this webinar has been recorded and it will be available for viewing on grainnet.com within 24 hours. All registrants will also receive an email containing a link to the webinar recording. Our next webinar will be held on Thursday, July 11th at 10 a.m. Central Time. Richard Jelinek and Jake Moline of INTL FC Stone will be discussing the importance of risk management to grain elevators and their customers. I want to thank you all for attending, and I wish you all a great day.
Thank you.